Okay, let's go over this worksheet that you had to do last night. And I'm going to start with number 2. Now you may have had other questions than these, but if you can do this one, you should be able to do number 1, and you should be able to do 1 and 2 on the other page as well. This is the first page, page 26. Okay, we'll write that down. Page 26. Okay, I'll just stick with the first worksheet. Like I said, if you can do the first page 26, you should be able to do page 27 as well. Let's see, where do we have to do? Oh, find the sine, cosine, tangent of angle R, and find the sine, cosine, and tangent of angle S. It's not really much work. It's just a matter of writing them all down. So let's find the sine, cosine, and tangent of angle R. Now we're not actually solving for angle R. We're just finding the sine, cosine, and tangent of these, which is just a matter of writing one over the other and simplifying. So the sine of R. So here's angle R right here. Sine is the opposite over the hypotenuse. You just have to remember those. I'm not going to write them down. It's SOHCAHTOA. If you forget, you got to memorize those things. So the sine of angle R is opposite over hypotenuse, which is 10 over 26. Always reduce it, so 2 goes into both of those, 5 over 13. That's the sine of R. Just keep it 5 over 13. I really don't want the decimal part. Even though the instructions say, I understand, it says write it as a decimal, but I don't care. I want the fraction. Okay, so on a quiz or a test, don't write it as a decimal. Keep it as a fraction, a reduced fraction. So that's how I want you to write it. Okay, cosine. The cosine, excuse me, the cosine is the adjacent over the hypotenuse. So it's 24 over 26. 2 goes into both of those, 12 times, 13 times, and that's how you want to write that answer. The tangent of angle R is the opposite over the adjacent. So it's opposite over the adjacent, 10 over 24. Reduce it, 2 goes 5 times, 2 goes 12 times, and there it is. That's what they are right there. Alright, now we have to do the same thing for angle S. See, the work's not that hard, it's just a little bit of writing. So let's write down sine, cosine, tangent, but we're doing this for angle S this time. Alright, let's see what we have. So we're going to come up here and we're looking at this angle. And we're finding the sine, cosine, and tangent. So the sine is the opposite over the hypotenuse, 24 over 26. And I want you to see a little relationship after we're done doing this. 24 over 26, that's 12 over 13. The cosine of this angle is the adjacent over the hypotenuse, 10 over 26. Reduce that, 5 over 13. And let's do the tangent of angle S. The tangent is opposite over adjacent, 24 over 10. Reduce it, 12 over 5. I just want you to see something. Look, the sine of the angle of angle R is 5 over 13. Let's go down here and find the let's see, the cosine of the other angle. Look, the sine of one angle and the cosine of the other angle is exactly the same thing. They're both 5 over 13. That's pretty interesting. Look at this, the cosine of R and the sine of S. So the cosine of one angle and the sine of the other angle, look at that, they're both the same thing, 12 over 13. That's pretty interesting. Look at the tangents. The tangent of one angle and the tangent of the other angle are just inverses of each other, 5 over 12, 12 over 5. That's pretty interesting too. Just wanted to point that out to you. Alright, let's go on to the next type of problem you had on the worksheet. Okay, let's go to number 7. I don't know, just pick that out of the blue. Looks a little different than what we've done before. So what we have to do here, it says use a special right triangle to express each trig ratio as a fraction. But then it says as a decimal, but I don't care about the decimal. I want you to express it as a fraction. So this is a special triangle because it's 30 degrees. It's not just some random angle. They picked a specific angle, 30 degrees. Sometimes they use 30, 60, sometimes they use 45 because those are special triangles. So I draw a special triangle. We'll call that 30 degrees. If that's 30, that's 60 up here, and we want to find the tangent of this angle. And we don't know any of the sides. But do you remember what we did? We did this yesterday. we make the shorter side. You can make it anything. You can make it a regular number if you wanted to. Let's just make it something. Let's make it 5. Okay, I could call it any number I wanted to. It doesn't matter. When we did it before, we made it x, which represents what? Any number. All right, let's just make it 5 right now, though. And so I want to find what the other sides are. There are special relationships between these sides on a 30, 60, 90. So this is the short side, it's 5. Remember, the hypotenuse is twice as big as the short side, so this would be 10. The longer leg is the square root of 3 times the short side, so this would be 5 times the square root of 3. Right? You could have made this x, this would have been 2x, this would have been square root of 3x. But I just decided to pick just some random number 5. And let's find the tangent. The tangent is what? Opposite over adjacent. So let's write it like this. We write the tangent of 30 is equal to the opposite. Opposite of 30 is 5. Opposite over adjacent, which is 5 square root of 3. Now we simplify this. We got to simplify this thing right here. Look what happens. 5 goes into 5 one time. Make sure you put the 1 up here. So it's 1 over the square root of 3. But we don't want to leave it like that. We don't like a square root in the denominator, so what do? We get rid of it by multiplying the top and the bottom by the square root of 3. We've talked about that before, so that shouldn't be new. And then let's simplify it. That's square root of 3 over square root of 3 times square root of 3 is 3. That's the tangent of 30. That's how we write it, just like that. So that's what they're asking you to do on numbers 3 through 8. All right, pretty much the same thing. Sometimes they go 45 degrees, sometimes 60, sometimes 30. You just draw your special triangle, make your sides. You can make this anything, but remember there's a special relationship. If you make this 5, you have to make this 10, and you have to make this 5 square root of 3. I could have called this x if I wanted to, and it would still work out exactly the same way. So I hope that helps. Alright, let's take a look at this thing. This is just a right triangle. They give you one angle, and they give you just one side, and they ask you to find the other side. So let's take a look. We are talking about this angle right here, 36 degrees. Let's find the relationship between the other two sides in this angle. Alright, are they opposite, adjacent, hypotenuse? What are they? So look at this one. This one is opposite of 36. This one is adjacent to 36. Which one is opposite and adjacent? That's the tangent. So you take the tangent of 36 degrees equals the opposite side, which is x, over the adjacent, which is 7. This math is really easy. X is already on the top, so it makes it pretty simple. Multiply both sides by 7. I always put it out front here, okay, and then we chuck that into a calculator. Alright, here's my calculator. Sorry. Try and clear this thing out. So how do we do this? This is not a division this time. This is multiplication. It's 7 times the tangent of 36. A couple ways to do this, but on this calculator right here, all you got to do is hit 7, hit tangent. You don't have to hit inverse this time. We're not doing the inverse tangent. We're actually taking the tangent of 36 degrees. So you hit 36. I don't believe you have to close it, but I do. And then you hit enter, and there it is. It's 5.08. Let's round it to 5.1. So what did we just find? We found the length of that side of the triangle, and that's just 5.1. So if you want to put that right there, you could. Now if you wanted to, they don't ask you to do this. Oops, sorry. Oh my goodness. Let's get back to where we were. Let's go way down here. There we go. Let's scooch up. Okay. If you wanted to, you could find AB. They don't ask you to do that, but just in case at some other point they may ask you to find that other length. You could do the trig function if you wanted to, right? You could have gone, this is hypotenuse, and you knew this one originally, so adjacent hypotenuse. You could have used the cosine of 36 to find this. Or, you know this is 7, you know this is 5.1. You could use Pythagorean theorem if you wanted to solve for AB. So there's all kinds of ways you could find the other missing parts. You could find this angle B very easily just by subtracting from 90, 36 from 90, 90 minus 36. So anyway, just wanted to point those things out to you. Let's do one more type, and then I'm going to teach you something else. Okay, here's another one. This time they actually, now it's kind of weird how they wrote this. I'm not sure if they made a mistake or what the deal was, but anyway, they put an X right here thinking that, oh, you have to solve for X, this angle, but they actually tell you to solve for angle B. So solve or find angle B. That's what we're looking for, is this angle right here. Even though they put the X there, that's kind of weird. I'm not sure why they did that. Maybe it's an oversight. I don't know. Anyway, let's solve for angle B. That's what they tell you to solve for. So let's figure it out. We know these two sides right here. So let's use those two sides, find out what they are. Are they adjacent? Are they opposite? Are they hypotenuse? So according to this angle right here, this 6 is adjacent to this angle B. 18 is the hypotenuse, no matter which angle you're talking about. But this is adjacent to angle B, and this is hypotenuse. Which trig function uses adjacent and hypotenuse? You write out the SOHCAHTOA thing, and you'll find out it's the cosine. So it's the cosine of angle B is equal to the adjacent over the hypotenuse. Adjacent is 6, hypotenuse is 18. You could reduce this, I guess, if you wanted to. You don't really need to, because we're just going to chuck this into a calculator anyway. Alright, so here's the calculator. Let's clear that. And we have to solve for B, not the cosine of B. Now, at this point, you're going to get used, hopefully you'll get very used to just knowing what to do in this situation. But let's write it out. Remember what we're doing. We're taking the inverse cosine of both sides. So if we take the inverse cosine of this, it'll go away. But I also have to take the inverse cosine of the other side. Remember, we're not dividing by the cosine. That doesn't make sense because the cosine is not a number. It's not a variable. It's just a word that describes a relationship. Okay, so we can't divide by it, but we can take the inverse of it. So this is what I'm putting into my calculator. I like this notation because it looks very similar to the notation on the calculator. So let's do this. Second function, cosine. That's what that is. It's the inverse cosine. So I hit second function, and I hit cosine. See, it looks just like that on the calculator. Then I hit 6 divided by 18. And again, you could reduce it if you wanted to. It'd be 1 over 3, but it's just as easy to put 6 over 18 in the calculator. And then you hit enter. And there's your angle right there, 70.5 degrees. So angle B is 70.5. Now remember, it's not the length of a side, it's actual an angle. So it's 70.5 degrees, and that is your answer for angle B. So that pretty much does the worksheet. Let's I'll do this on another video, but let's do the next lesson, which would be what, 8.5. Okay. Yep, that's it. Sorry.